Hello there and welcome to this module. So what are we going to do? Let's find out. So we're going to continue on our code-based testing journey. What is code-based testing journey? Well, looking at those statements, looking inside the box, as we call as white box testing. So we have got three things out over here which we're going to talk about. Data flow testing. We're going to look at the path-based testing metric. So we looked at path-based testing. We'll kind of extend it further and look at the metric part of it. And of course, we'll look at a couple of examples. So let's dive in. Data flow testing. It's a structural testing. All our code that we write, there are variables, there are data structures, there are those structures which actually get values, and then the moment you've got those values, we actually make use of them. So we do both. They receive values, and that is when we look at how these values are used or referenced. So the piece that comes in is that there is a path that we follow, which is a control flow path. And then now there is a data flow related piece that we look at. I create somewhere, I define somewhere, and then I use. So this is basic set of definitions that talks of data and is also going to provide a reality check over path testing. After all, a lot of stuff is about data manipulation most of the times, or paths are even decided based on certain values. So what we look at when we test, we look for problems. So what problems are we expecting? A couple of problems that we'll expect is a variable that is defined but never used. So that's what we'll get into. A variable that is used but never defined. Okay. A variable that is defined twice before it is used. Generally, compilers take care of this. And then we could look at finding faults in code without executing it. So that's the static analysis piece that we can look at. So at this point, as we proceed, there are these things where I would love to mention about the define and use testing. So we look at define, use. So we could look at define, use, and kill. And we could look at pairs. So for example, I do a define and define, I do a define and use, define and kill. I do a use and then define, I do a use and use and kill and define, kill and use, kill and kill. Such pairs can actually help us in analyzing pieces of code. And our focus is going to be on the DU pair. A lot of pieces which help definition and use. So let's see what we have as a part of our DU testing. Here we'll look at a particular graph. So we're going to look at a graph. One entry, one exit, and something happens in between over here. There are paths. So now we start looking at defining node, where the value of the variable is defined. All input statements, assignment statements, loop control statements, and procedure calls could be defining node. So is what we have use node. Variable v is used. That's how we get the DU pair. We've got the define and use pair. Output statements, again assignment statements. Conditional statements, loop statements, procedure calls. So a usage node has two parts, a CUse, where there is a computation use, and then there is a PUse, which is a predicate use. So we can have either a C use or a predicate use. C use or a P use. That is computational use or a predicate use. Which helps us understand what kind of use is for that particular variable. So a DU path now is going to be of those nodes where there is a definition that is happening and a use that is happening in that particular entire graph. Then there is a definition clear path. So you have a define and use, but define and clear path also can come into play. Now let's look at concept of data flow. And data flow concept is from a testing perspective now. So data flow testing. So we use data flow or flow of data and its information for design of test cases. And that's where we follow the DU pair, where there is a statement that assigns the value and then there is a statement that makes use of the value. So let's look at these examples here. You've got V equal to X plus 4, that's definition of V. Input of V, read and assign a value to V, hence it is again a definition. Now let's look at the use. Z is equal to V plus 1, which is a use of V. If V is greater than 0, again a use. Printf of V, again a use. V is equal to V plus 1 is also a use of V. Thus we come up with a definition use pair. There exists a DU pair between two statements, D and U, if D is a definition of the variable, U is a use of the variable, and there exists a control path from D to U along which the variable is not modified. All three have to be satisfied. Let's look at an example. I think it's all in front of you. So we have these 5 statements. Again, this is a concept example. I don't believe anyone would write code like this from a product perspective. So we have got input x comma y, z is equal to x plus 1, v is equal to x plus y, x is equal to 0, and w is equal to z plus x. So let's go variable by variable. Variable x. X is defined in 1 and then used in 2. X is defined in 1 and used in 3. And x is further defined in 4 and used in 5. So that's how these are the ones that come in. And let's specifically make a note of wherever we find x, 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 and x. Next, let's look at variable y. Can you find out what's happening with variable y? Let's use another color. Y, y. So that's what we have, something between 1 and 3. Is it a DU pair? Yes, it is a DU pair. It's a definition and use pair. Let's look at z. Where do we have z? Do we have another color? Of course we have another color here. So we have z, and where else is it? Z is here. 2 and 5, again a definition and use pair. So you can see how we have gotten the DU pairs for each of these. So between 1 and 5, we are making a very clear-cut note and would want to be true to our definition of definition and use is between 1 and 5, so there is x here defined and used in 5, but remember we do not want it modified in the control path, in the control flow that we have, because x gets modified at 4. This is a fundamental concept and the basis for the data flow testing. automatically detected in the static code, where you can actually run through code during compilation or like reading the code. One will be able to find out very clearly as to what's happening with the DU pairs. We may have variables which we define and never use. So we could look at all those combinations which we wrote over here. So let's proceed and understand where we could further make use of this. But before that, let's understand how are we going to make use of this. So we'll identify all the data flows, and then we design a set of test cases that each data flow DU pair is executed at least once. Right? So that's our basis that we get to. And what are the salient features here? Well, it can detect really good defects. It is very demanding technique. You got to really spend a lot of time. Of course, with today's tools, you may not have to spend so much amount of time and effort, but it is indeed effort intensive. And it does require an effort to design very good test cases. You would see in the example that we are actually going to go through as to it really requires a lot of effort to design those test cases. So in our next topics, we will look at the example, but that's what DU pair is all about. It opens up the definition use piece and looking at variables and data part of it. Thank you.